about solving exponential equations. Now there's two ways of doing it, using logs, and this one is about using powers. So what do I mean by powers? Well, things being raised to an exponent, and then you multiply the stuff out. Now here's a table for them, the numbers 1 through 10. 1 through 5, I took them to the 10th power, and then 6, 7, 8, 9, and 10, we just did up to the 5th power. Now the idea here is that you can look at either side, right? This side or this side, and you can tell me the equal part of the other side. For example, right here, if I wanted you to rewrite each of the following with a different base. Now what does base mean? Base is the number being raised to the power. So what you would do is look back on your table. We want it to be 2 to some power. And that's got to be the same thing as 4. Well, that one's easy. I know we can do that in our head. But if you look at the 2 line right here, it says 4 is the same thing as 2 squared. So we would say that 4 is 2 squared. Simple as that. Okay, this one right here. 216 is 6 to what power? Well, let's look back at our table. We're looking in the 6th group right here. 216 happens right there when the power is 3. Okay, 512. Looks like we're in the 2 column. So a 2 to some power equals 512. Okay, 2 column of 512 is right here at 9. So 512 is 2 to the 9th power. Right? 2,401 is the same thing as 7 to the 7 column. Looks like it's 7 to the 4th power. Next one, 15,625 is the same thing as 5 to the 6th power. So you see what I'm talking about? All we're doing is looking at that table and trying to figure out how to rewrite that big number as just a power. So 4, let's see, we're going to 4,096. It's right here, so that's going to be a 6. Okay, 64. I want to know what that is as 8 to some power. Again, that might be one you already know. If you look down the 8 column, 8 to the 2nd is 64. Okay, this looks like 100,000 is 10. Now, if you look at the 10 table, it's kind of cool. Right here, 10 to the 1, there's 1 0 on it. 2 means 2 zeros. 3 is 3 zeros. 4 is 4 zeros. 5 is 5 zeros. So you really just have to count the number of zeros. 1, 2, 3, 4, 5. So it's 10 to the 5th. Okay, last one. 6,561 is the same thing as 9 to the 4th power. Okay, so as far as exponents and powers, all that stuff, hopefully you can see where I'm getting all these numbers from. Now, the reason we do that is because there's this property or this rule that says if the bases match, then the powers match. So what that means is if I tell you that I've got 2 as a base here and 2 as a base here, then I can take those powers and say, well, hey, if the bases match, check, then the powers have to match. Well, that means that this power equals that. Okay, all I did was I said the bases match, so then I can take those powers and say that they're equal to each other. This one says 3 to the 4x equals 9. The bases don't match, but using the tricks that we just used, I can say 9 is 3 squared. Now I can say that since the 3 and 3 match, then these two things in the powers are also the same. Powers match. 3 and 3 match. 4x and 2 equal, 4x equals 2. Okay, next one. Ask yourself, do the bases match? They do. They're that E guy. Doesn't matter. They're the same, which means that the powers, this guy, 2x, and this guy are the same. Now, when I say the powers match, that's what I'm talking about. They're the same. Which the same in math means equal. That's why I put these little equal signs in here. Now, what does that do for us? What that tells us is if this is true, x minus 4 equals 3, then we just have to figure out what x makes that true. And we've now, quote unquote, solved for x. So I gave you this exponential equation with a variable up in the power. And if I say to solve for x, this is the only way to get that exponent, or sorry, that variable out of the power. All right, same thing with this one. I gave you this equation in the beginning that said 3 to the 4x power equals 9. And if I said solve for x, this is the only way to do it. So you end up with 4x equals 2. Now if it's 4 times the variable, the reverse of that would be to divide. So we get x equals 2 over 4, which reduces down to 1/2. Or if you pop that into the calculator, I'm okay with 0.5. Okay, this other one, a little bit trickier. But all we have to do is get the x's on the same side. So I don't know if you remember, you subtract this x from both sides so that you have 1x equals -3, and that would be the solution there. Okay, that's the whole point of this lesson, is to say, okay, if you can make it look like this, or this, if it's an E, then whatever these two are, you can make into an equation. Now mine just say x and y, but they're obviously going to be different things. Like this one was x minus 4 and 3. And all I did was make an equation out of it. So back over here, this says 2 to the x equals 4. Now I've got to change this guy into 2 to some power so that I can take that x out of the power and make an actual equation that says x equals, and that will be my answer. So if you look back here at our power table, the thing we did, right, we rewrote all of these. If you look back at our power table, I want my base to be 2. I'm looking at the number 4, all right? So 4 is the same thing as 2 squared, which means x and 2 are equal to each other, and I've solved. Now that's a lot of 2, so let's try another one. All right, here we're on this one. We've got 6 to the x, and I need this side to be 6 to some power. Again, we'll go back to our table. We're looking at the 6's now, so I'm now this column, and it looks like 6 to the 3rd is what equals 216. So right here, instead of 216, I'm going to write 6 to the 3rd. Now, according to that last property, the thing I just showed you, that then means that x and 3 have to be equal to each other. And that's the solution to that one. Okay, let's try this one. 7 to the x equals 7 to, I don't know, 2,401. So I'm going to go back to my table. I'm looking in the 7's column, and I'm looking for 2,401. That happens when 7 is raised to the 4th power. So instead of 2,401, I'm going to write it as 7 with a 4th power. Okay, what that tells us is that because the 7 and 7 bases match, I can say that x equals 4. Okay, next one. Let's go with this one. We've got to rewrite 15,625 as 5 to a power. That's going to equal 5 to the x, and that will tell us what x is. Okay, back to our table. Down the 5's column. It's right there. Looks like 6 is our number. So this is 5 to the 6th. 5 to the x. That means x and 6 get to be equal to each other. Right, moving a little bit faster. That's a nice little squeak. Going back. 4 and the 4,096. That was 4 to the 6th power, which means x equals 6. Okay, last one. Again, I gave you the shortcut for tens, but we'll still use our table. So 10 to the x equals 10 to the question mark. The shortcut was if you count the number of zeros, but just to double check on our table, there were 5 zeros, 1, 2, 3, 4, 5, so it's 10 to the 5th. So 10 to the 5th equals 10 to the x, which means x equals 5.